puzzles and games. Puzzles and games challenge you to think critically and creatively as well, improving your ability to solve complex math problems. They make learning fun and engaging, sparking your interest in mathematics. They also promote exploration and experimentation, allowing learners to discover and understand mathematical principles on their own. Trying math-based puzzles like Sudoku, logic games, or even math-based board games can challenge your thinking in a fun way. Another thing to look at, the problems like these provide an artistic way to look at linear equations. Speaking of art, I personally love art, but I never really thought math would be a part of it until I started making mandala. And ever since then, art and math have been an unstoppable journey for me. I mean really, art and craft can be powerful tools to sparking your interest in mathematics by making abstract concepts more tangible and interesting. And a very prominent way to do this is by hands-on learning. For example, craft activities like building models, creating tessellations, allow students to physically manipulate materials, reinforcing concepts like geometry, spatial reasoning, and measurements. Art creates compelling visualizations out of mathematical data. For instance, students can turn statistical data into artistic graphs, making abstract numbers look more comprehensible and interesting. Art involves areas of symmetry and geometric shapes. By creating mandalas, origami, or even kaleidoscope designs, students can have a hands-on and creative experience on these topics. Speaking of mandala is a very interesting concept because there is symmetry in the radially outward design of it, and when you deeper dive into the shapes inside it, it opens doors to the mathematics like trigonometry and similarity. Also, speaking of origami is not just an art but also a subject of mathematical study that helps us to solve geometrical problems and prove theorems. For example, the Husita-Hattori axioms are a set of principles that describe the mathematics of paper folding. Speaking of origami, even I started doing origami, but I found a flaw in myself while creating flowers. And when I discovered more of them, I came across math and nature. It's fascinating to see how math appears in our natural world. Here are a few key examples. First one is the law of nature, the Fibonacci sequence, that can be observed as a growth pattern in various plants. For example, sunflowers and pine cones, where it is exhibited as a growth pattern when each number is the sum of its two preceding ones. Derived from the Fibonacci sequence is the golden ratio, approximately 1.618. It also appears in various natural forms, from the branching of trees to the arrangement of leaves. Next one is fractals. Fractal patterns are evident in various natural phenomena, from the structure of coastlines, the formation of snowflakes, or even the branching of trees. Next one is symmetry. Symmetry can also be observed in various organisms. For example, the bilateral symmetry of the butterfly and the radial symmetry of the starfish are key to its structure and functions. Next one is mathematical proportions. Mathematical proportions can be seen even in a human body, our face, or even in the way seeds are arranged in a fruit. I personally as a kid was not interested in math, but I was fascinated by nature, and that gave me the motivation to seek out math in our everyday aspects of life. Teacher, next one. So you see, math can be related to coding, music, sports, finance, or everything that you name. Math is related to coding because coding often involves logic, algorithms, calculations, data structures, or as simple as creating a logo using shapes. Math is related to music because beats and time signatures follow mathematical fractions and patterns. Also, pitch notes and specific frequencies which are mathematical ratios. Math is related to sports because points and scores are tagged using basic arithmetic. Also, player and team stats are calculated